All right, we are going to go through the second set of topics on simplifying radical expressions. Today we're going to talk about adding and subtracting and multiplying terms with radicals. We will begin with adding and subtracting. Real quick review on like terms. Like terms have the same variable portion. So when we look at 2x to the third and 5x to the third, we can say that they're like terms because they both have an x, both to the third power. So when we add or subtract, we combine the coefficient, and remember that's just the number in front of the variable, and we keep the variable portion the same. So that x to the third stays the same. We don't do anything with the exponent or anything with the x. So on number 1, when we have 2x to the third plus 5x to the third, 2 plus 5 is 7, so we will have 7x to the third. Likewise on number 2, 8x squared plus 4x squared will just give us 12x to the second. Okay, so now we're going to go ahead and apply what we know about like terms to radicals. So likewise, expressions with radicals are combined the same way. We can add or subtract if the radicals are the same. Now it says watch out, simplify first as possible, and we'll get into that when we look at the second line of problems. So when we do 3 times the square root of 7 plus 4 times the square root of 7, they both have a square root of 7, so we can just do 3 plus 4, and we will get 7 root 7. And that's all we need to do. We can't simplify 7, no perfect squares go into it, so that's our answer. Next one, the square root of 2 plus 4 times the square root of 2. We can put a 1 in front of the square root of 2 if we would like, and 1 plus 4 will give us 5. We can't simplify the square root of 2, so we're done. And number 3, when we do a subtraction problem, 8 root 7 minus 4 root 7, we'll just do 8 minus 4, and we will get 4 root 7. 7 has no perfect squares, so that's all we have to do. Okay, when we look at number 4, and we want to do the square root of 2 plus the square root of 18, the square root of 18 is not the same as the square root of 2, obviously. We need to simplify 18. So we'll break that down to 9 times 2 because 9 is our perfect square. We'll break that down further to the square root of 9 times the square root of 2. And then that'll be 3 square root 2. We can bring down the original square root of 2 plus, and then we can just do that. So we will do 1 root 2 plus 3 root 2 and get 4 root 2. All right, number 5. 27, we need to break that down to 9 times 3. Square root of 9 times the square root of 3, which is then 3 square root of 3. Bring down our plus root 3, and then we will add them and get 4 times the square root of 3. All right, number 6. We've now got 3 root 2 minus 10 root 18. So we need to first break down the 18. So 18 will break down to 9 times 2, square root of 9 times the square root of 2, which is 3 root 2. So that's just the part of the 18. So we have to include our 10 in the front now. So 10 times 3 root 2. And that 10 comes from up above. So that'll be negative 30 root 2, and we'll bring down the 3 root 2. And then we can do 3 minus 30, so negative 27 root 2. Can't simplify the square root of 2? Shall we move on? Yes, we shall. Okay, now we're going to use the distributive property. So we have to remember our rules for multiplication. So if things are inside the square roots, they can be multiplied, and if they're outside the square roots, they can be multiplied. So we can put our outsides and our insides together. That's what we need to remember. It might be helpful for you to put a 1 in front of the square root of 3, just to keep that in mind. And then we can just draw our lines to distribute. So 1 times 3 will give us 3, and then the square root of 3 times the square root of 2 is square root of 6, plus 1 times 5 is 5, and the square root of 3 times the square root of 6 is 18. Now this is a great start to an answer, but we have to first check, can we simplify 6 or 18? And we can simplify 18. So that will break down to 9 times 2, So that 3 root 2 is going to replace the square root of 18. So then we need to bring the 5 down and do 5 times 3. So we have 15 root 2, and we won't want to forget our 3 root 6, and then our plus sign in between. This is going to be our answer because the square root of 6 and the square root of 2 are not like terms. So there we go. Number next. The square root of 5 times 8 root 2 plus 5 root 6. We can go ahead and distribute. So we will have 8 square root of 10 plus 5 times the square root of 30. Now no perfect squares go into 10 or 30, so we're going to be done. Now I know it's frustrating here because problem 7 and problem 8 look like they have the same amount of work, but do we see that number 7 we have quite a bit more work involved. So you need to really be thinking when you're going through these what can go into these that is perfect squares. Oh good, we have a dress. Yay! Put some earrings on her. Is that a bow? Lovely. All right, we'll draw a dude next time. Okay. I think Miss Cash, if she ever wants to go into a new field, graphic design would definitely be it. Alrighty, onward. Let's go ahead and do some distributive property. So this we have a number on the outside as well. So we'll do 4 times 8 and we'll get 32. Root 5 times root 2 is the square root of 10 plus we'll have 20 times the square root of 25. Now this is supposed to be easier and ends up sometimes being more difficult. The square root of 25 is a perfect square. So the square root of 25 is just going to become 5, so we're going to do 20 times 5, which will give us 100. So we see on this problem, on that part of that term, we do not have a square root. And that right there is going to be our answer. Okay, on this one we have negative 10 is what we're going to distribute. You can pretend that that's negative 1 times the square root of 10. We distribute, so we'll have negative 7 times the square root of 20 plus a negative 1 times the square root of 50. Again, if you just want to put subtraction sign instead of plus and negative, that's just fine. So we need to go ahead and we need to simplify the square root of 20 and the square root of 50. So remember, you're thinking what perfect square goes into 20, and that would be 4 times 5. And we'll bring our negative 7 down. So we have negative 7 times 2 root 5, which will give us negative 14 root 5. And then we'll simplify the square root of 50. What goes into that? That is a perfect square. That'll give us 25. And then in this case, the only thing we need to bring down with it is the subtraction sign. So our answer will be negative 14 root 5 minus 5 root 2. Again, those two problems look pretty similar at the beginning, but one has more work than the other, so you really have to be careful. And the last thing we're going to talk about is what happens when we're multiplying two binomials. I know in Novotny's class we learned the FOIL method, which is first, outer, inner, last. And in Cash's class you did her, is it the box method? So we're going to show you guys what that's about. We're actually going to start with the second problem. So which one are we going to do first? Alright, first we'll do the FOIL. So that means we're going to multiply the first terms together. So root 3 times 1, which will give us the square root of 3. The outer terms, which would be the square root of 3 times negative 6 root 2, which gives us negative 18. Oh no, it gives us negative 6 root 6. Oh goodness. The inner terms would be 4 times 1, which is just 4. And then the last terms would be 4 times 6 root 2, excuse me, negative 6 root 2, which gives us negative 24 root 2. Now we look at those four terms. None of them are like terms, so we can write them as our answer. So the square root of 3 minus 6 root 6 plus 4 minus 24 root 2. Now we're going to sit back and be amazed by this box method. So she draws a box. She puts 4 boxes in there. And then, okay, so the square root of 3 and 4 goes on the vertical, and then 1 minus 6 root 2 goes on the horizontal, and then I think she just multiplies. So root 3 times 1 is root 3. Oh, this is neat. All right. So do we see we just have those same 4 numbers, but they're in a box form? Look at that, I learned something new. Wow, woo! Okay, so for that first problem, let's go ahead and we're going to use this box method because I just learned it and I'm pretty excited about it. So we set up our box, and you can do FOIL if you would prefer. So we'll put the square root of 2 and 4, and then 1 and negative 5 root 2 on the other side. Then we just multiply. My mind is blown here. Okay, so then we write it in one answer form line, right? Okay, yes. So that line in red that she wrote below the box, you would get that if you FOILed. And now we have to check what can we simplify or combine. So I'm looking at 5 square root 4, and I know that 4 is a perfect square. So that's just going to become 2. So we're going to do negative 5 times 2, and that'll give us negative 10. And then we can bring down the rest of the problem. So the square root of 2 plus 4 minus 10 minus 20 root 2. And we can combine our like terms. So our two like terms have the square roots of 2. So we'll do 1 root 2 minus 20 root 2, which will give us negative 19 square roots of 2. And then 4 minus 10. Crossing my fingers that we're going to get negative 6. And there's our answer. Okay, hopefully this has made some sense. So let's have you, if you guys want to try these problems at home, you can check them here or they're right on your worksheet. And I think if we leave lots and lots of loving comments to Miss Cash, I can get her to be the narrator. I bet I can, but we'll see. So let's give this a try. Comment away. Have a lovely night. Goodbye.